Good morning. Welcome to the first plenary speech of this conference. My name is Guishen Chen. I'm under the Institute of Atomic and Molecular Sciences in Academia Sinica. This is the institute across the street. So when you have time, please welcome to IAMS. And today, I would like to introduce our plenary speaker. Before I do that, I would like to welcome all the attendants, including the people online, to come to Taiwan when you have a chance. Now the COVID-19 is gradually ceasing, so we will be open up to welcome international visitors. When we talk about Taiwan, of course, most of the people immediately think the high-end semiconductor. But more than that, Taiwan is well known for freedom, democracy, as well as safety in the international society. And when I come this morning, I come to this question: what is the major concern people have nowadays? I think the first of all is COVID-19, or Omicron, which you can see on the mask that I'm wearing. Secondly, also show on the mask the color of blue and yellow. This is Ukraine and Russian conflict. We hope that can come to an end pretty soon. Thirdly, which is very much associated with this conference, is climate change and this global warming issue. So with that, I introduce today's plenary speaker, Professor Yuan Li. He was born in, 1936. Now he's at the age of 86. He got his degree from National Taiwan University, the bachelor degree, and then Tsinghua University, the master degree, and then he went to UC Berkeley to get his PhD. After that, he went to Harvard as a postdoc, and then continued to University of Chicago as assistant professor, and then continued to UC Berkeley as a professor. And he also worked heavily in Lawrence Berkeley Laboratory. And he came back to Taiwan and became the president of Academia Sinica in 1994, and served more than 10 years in Academia Sinica. After he retired, he was elected as the president of International Council of Science Union, ICSU. And as a president, he worked till 2011. So he has received many awards. I only mention one, which is 1986 Nobel Prize. And he also received a total of 42 honorary degrees from universities worldwide. So with that, I would like to pass my microphone to Dr. Yuan Li.
So, thank you very much for the introduction, Dr. Chen. Ladies and gentlemen, I'm very happy to be here with you. Today, my lecture title is a little somber. We do not have much time left. When I say we, I don't mean myself. I certainly don't have much time left. But what I'm talking about is humanity as a whole do not have much time left if we continue to behave the way we have been. Well, after the Big Bang, universe was created. It took about 9 billion years before the solar system was formed. At that time, solar system was hot, the Earth was very hot, and if you look at the atmosphere, some 4.6 billion years ago, it means after the formation of solar system, 4.6 billion years has gone by. At first, most of the air are methane, ammonia, water, helium, hydrogen. Helium and hydrogen escape very quickly. And as the surface of the Earth cooled down, water condensed, become ocean, and methane, ammonia, all transform as well as carbon dioxide. So if you look at the composition of air about 1.8 billion years ago, it mainly oxygen and nitrogen where we live today. And actually, during the last 10,000 years, the Earth was quite stable. Life started, human appeared, and the period we used to call Holocene is quite stable. But things started to change. The change started during the Industrial Revolution. That was more than 250 years ago. Before Industrial Revolution, we only depend on sunshine, vegetation, food, and fuel all came from sunshine or through vegetation. But after Industrial Revolution, we started to burn coal, oil, and natural gas. And among the oil, among the natural gas and coal started to increase. So you can see by today, 2020, most of the energy we're using came from the fossil fuel. Around that increase of energy, we also see the enormous increase of human population. As I said, after the Industrial Revolution, 200 some years ago, population went straight up. By the time in 1950, people said the Earth can support about 2.5 billion comfortably. But we passed that mark long time ago. Non-reserve renewable resource depletion continues on and on and on. Now we have more than 7 billion people on Earth. It's a large number. And because of the production, consumption, with the increase of population, Earth itself has changed. But change is slight. We all live in a very thin layer, or atmosphere, hydrosphere, all live in those thin layers. And we are changing the atmosphere. The change is slight, but yet quite significant. So let's look at the chemistry of atmosphere. We're on Earth, and sunshine irradiates the Earth daily, and the spectra of sunshine, because temperature is high, UV photon is abundant. But those UV photon and VUV photon are absorbed in the upper atmosphere, mainly in the stratosphere. So oxygen will become ozone, ozone will absorb UV until around 3,000 angstrom. So the photon rich Earth are mostly visible, which is helpful to mankind because of the vegetation, but it's not harmful to human being. But I said human activity started to change the composition even slightly, yet it could be quite serious. I don't know how many of you are born around early 1970, probably none of you. In early 70, Boeing was suggesting to make supersonic transport. Airplane will fly so high and so fast. And our airplane is flying even more higher than 8 kilometers now, more than 10 kilometers. But at that time, they're suggesting maybe fly up maybe 20 kilometers. But because engine will become very hot, so that supersonic transport will produce nitric oxide. And at the time, Professor Harold Johnston at Berkeley, who studied chemistry of nitric oxide all his life, he said, wait a minute. We know the Chapman cycle plays the most important role in the upper atmosphere. It means UV and UV photon is absorbed by O2 and produce oxygen atom. Then oxygen will react with O2 to form ozone. Ozone can absorb UV up down to about 3,000 angstrom and dissociate back to O2 and O. The Chapman cycle is the one which produces ozone and keep us safe. But if supersonic transport would produce nitric oxide, NO will react with ozone, produce NO2. NO2 will react with oxygen again and produce NO back again. So that will be NO cycle. So that small amount of nitric oxide could catalytically decompose ozone. So there was a lot of discussion in the Congress, in the scientific communities. And then, NO does not turn out to be as important in destructing the ozone. But there's a person called Sherry Rowland. Around that time, he was a hard atom chemist. He was investigating chemistry of energetic atomic species. The energy came from recoil or nuclear decay. When nuclear decay emitting alpha particle or beta particle, the recoil energy is high. So he himself called hard atom chemist. When he learned there are freon all over the world, distributed all over the world, freon was so stable, nothing seemed to destroy freon chemically. But he said, if freon was going to stratosphere, if freon absorbed UV or VUV photon, it will produce chlorine atom. Chlorine atom will react with ozone and form CaO. Then oxygen will pick up oxygen from CaO and reproduce Cl. So there's a catalytic cycle number one. It's called chlorine cycle. So although concentration of freon is not that large, but the catalytic reaction will deplete ozone, that will let UUV photon come to Earth and destroy cells and damage our plant. Mario Molina, working with Sherry and also some other person working in Germany, they all realized that the fluorocarbon is quite important. And at the time, they also said in Antarctic area, temperature is low. Once chlorine monoxide is produced, they could easily form dimer. Monomer would not absorb visible photon, but dimer would. So dimer will absorb photon and regenerate chlorine atom, and CO2 will release another chlorine. So the suggested catalytic cycle 2. So freon will go through catalytic cycle 1 and 2. 2 are mainly in the Antarctic cold atmosphere. Those scientists, especially Sherry Loran, are very tall and energetic person. He's a good basketball player, very good baseball player. Very often, when he suggests something like this, went to the Congress, business representative always tried to intimidate them and said, what you found is not quite true yet, have to prove. With Sherry Loran was questioned. You said, what did you say? And others were shut up. Then they had to talk back to Sherry Loran. He was really a strong, powerful person. But in 1987, in Montreal, people got together, scientists, politicians, and passed Montreal Protocol. And scientifically, it's proven freon will be bad for mankind, and reducing the use of freon, especially for developed country, and limit the use of freon in the developing country. So that Montreal Protocol is the first time scientists understand something, understand we are damaging the environment, and do something and take some effect. So it's interesting to see in the year 2000, in the Antarctic polar region, you see very low ozone concentration. You can see blue, this concentration is low. By 2015, it's largely recovered. Without Montreal Protocol, that would not happen. So this is really a victory of scientists. Scientists investigating many things, eventually feedback to the society and do something good. Well, that might encourage us that we really can understand something and do something. Well, human activity is still causing change in the atmosphere, because when GDP increases, consumption, production increases, we are dumping many things in the atmosphere, and many of you can see that the problem of pollution and aerosol is the main theme of this conference. In Southeast Asia, no matter where you go, in the wrong season, you do see lots of pollutions. Pollution will harm health. But there's one important thing people didn't realize as early is the greenhouse gas in the pollution that would not harm people, but still are changing the environment in a great way. So look at the carbon dioxide concentration during the last 400,000 years. Every 1,000 years, there's some oscillations, because the relation between Earth and planet in the solar system and stars nearby, we do see the fluctuations. But highest historical carbon dioxide level never exceeded 300 parts per billion. Not until the Industrial Revolution, as the population increases, this number went way up, shoot way up. And that is really going to cause us lots of problems. So if you look at the atmospheric CO2 at Mauna Loa observatory more carefully. Just look at the line going up, look at carefully. You do see from 1900 to 2022, carbon dioxide still climbing up and up. The zigzag means 4 seasons. In the summertime, in the northern hemisphere, photosynthesis is stronger, so carbon dioxide is lower. Winter climb up, summer goes down, winter goes up, and this zigzag shows seasonal change. It's still going up at 420. We are at 2020. It's still keep on going up. And that's something we really need to worry. As I said, we live on the surface of the earth. The change we are making is part per billion, small amount, really very small. But the part per billion is enough to cause lots of change. One of the reasons is the part per billion we're talking about, so-called greenhouse gases, play quite important role in the energy balance of the sunshine, sun, and the earth. Okay. You look at the sun, temperature is said to be more than 5,000 degrees. So from the black body radiation theory, you know, sunshine emits most of the light in the visible in UV region, and then orders magnitude down by the time you go to the infrared region. But Earth is 300 degree K. Earth emits the energy, emits the photons, all in the infrared region. I cannot see. But sun gives the sunshine in large fraction is in the visible, in UV region. So because of the difference in the wavelength distribution, so you look at the Earth and the sun, the greenhouse gases show us the gray color. Sun can penetrate and go to the Earth. But the infrared emission, which is a longer wavelength, will be absorbed by greenhouse gas, show us gray color. So when the greenhouse gas become more and more concentrated, it will not influence the sunshine to coming in, but it will influence the infrared to go out. They absorb the infrared, so they create the imbalance. So although sunshine has been stable, but global mean temperature, if you look at the 1850 to 2018, it's rising for about 1 degree. And if you trace back a little earlier, before Industrial Revolution, it went up to 1.6 degree already. That is mainly because of the greenhouse gases, which absorb infrared, but will not absorb visible light. So that's a problem. Earth is so big. When temperature rises by 1 degree, the amount of energy is really enormous, an enormous amount of energy. When it fluctuates, causing typhoon and other things, it's really going to cause enormous trouble to us. So global mean temperature for 1850 to 2028 will go up about from 1950 to 1980, we're up to 1 degree. And the degree temperature rise, the rise of the temperature and the catastrophe which might bring is really quite significant. you look at these three panels, 4 columns shows the research done in different time. So just let us pay attention to the just pay attention to the extreme weather events. This was 201, 203, 214, this most recent investigation. So let's just look at the most recent investigation. Earlier investigation say it's not as bad when temperature rises to 2 degrees, but really it's pretty bad. This color shows undetectable, moderate, high, and very high. So when extreme weather events, when temperature rises to 1 degree, is in the orange color, and 1.5 degree is already in a very high climate change. Risk due to climate change will become very, very high. And we are working very hard, said, let's stop temperature rise to within 1.5 degrees. 1.5 degree is really not a good point. So if you look at the large scale singular events, again, 1.5 degrees is not very good. 1.5 degree for unique and threatened system is not very good. So I have a question. We work so hard. Are we going to make this world a better place to be? That's a good question. I have a granddaughter who lives in Hawaii. Last time he saw me, he said, yeah, you work so hard. I know you work so hard, although you're so old. You want to make this earth a better place to be, a better place for us. So she appreciated it. I told her, no. I'm sorry to say that Earth is getting worse. And what we are doing is trying to prevent the Earth to become so bad. We're trying to prevent the temperature rise to within 1.5 degree, not to within 2 degree, and 1.5 degree is quite miserable. It is far away from making this Earth system a better place for us to live. And she was disappointed. But I told her that that's the fact. That's the bad train. We are going up, and we have to bend it. But the future is not as you would like to see. And if younger generation believe that all of us are working so hard to make this Earth system a better place, no way, no way. 50 years later, young generation might try us. Said, how come? How didn't you make it a better place? How you're making this Earth a worse place to be? Well, that's the reality. 1.5 degree, we want to reach, not to exceed 1.5 degree. We are not reaching it. We will exceed it, getting worse. So this is really a sad issue. We say scientists did understand the ozone hole problem, they solve it. We understand the problem. We try to not to make it worse, but we have not found a proper solution yet. So temperature rise will cause lots of things. Those are Xiaolinsun in Taiwan. One day, it dropped the rain a little more than 1 meter. Then entire village is gone. 1 meter of rain in a day will cause that kind of damage. The next slide is California forest burning. This year is going to be even more serious. There's no water, no rain. And then a couple of years ago, you went to Osaka, you cannot land. Entire airport is frozen. Those are all the extreme weather events I'm talking about. When temperature rises, those kind of things will happen, or freeze and seaport. Or if you look at the Earth, there are places with a dust storm or burning fire, typhoon, and Earth is not as stable as I would like to see. And it's getting worse and worse and worse. And we try to make it not as worse. So, 1915, after I served for 7 years as the president of International Council of Science, everybody working so hard, trying to do something, nothing happened, nothing much have happened. But in December of 2015, something was exciting. This is COP21 in Paris. Politicians were finally awakened in COP21. They got together in Paris and said, yes, we have to do something. We do have to do something. And that meeting was during the Paris strike, moved the site to a different place. And during the conference, they came to these three conclusions. One is a non-binding global agreement to move towards the 2 degrees centigrade limit, and in parentheses said, and ideally to a 1.5 degrees centigrade limit. So COP21 is still talking about 2 degrees and ideally 1.5 degree centigrade limit. And the second thing is, every year, $100 billion will be transferred to a developing country to help them to delineate the global warming problem, and then to revisit carbon reduction plans in 2020. By 2020, we knew that we are not following the trajectory. We should bend the curve to 1.5 degrees, but curve is still going up. But 2020, the year 2000, at least people start talking about 1.5 degrees and talking about deep decarbonization. Really, we have to do deep decarbonization. But as I said, if you look at carefully for those years after COP21, carbon dioxide is still keep on going up, going up. There's no sign of it reducing it. It's 21. Again, summer, winter, summer, winter, still goes up. We have agreement to reduce it, but don't seem to be doing anything. So we do have to work hard. And that's a typical so-called capitalistic society, how it moves. The leader said, full speed ahead. GDP is going to increase by 4.5% or 5.3%. Well, that's what you heard every day on TV. You haven't heard our president said carbon dioxide will be reduced by how much. She already said GDP will increase by how much. Well, will be past Japan. At the same time, natural resources are sucking in, cheap labor are going in, produce lots of waste, and then pollution and carbon dioxide are keep on producing. And this machine has to change. This machine has to change. Could we consume a little less, use much less energy, then is progress. Progress does not mean keep on consuming too much energy. So when you see the society moving that way, and people seems also believe in the sustainable development, then you do have lots of questions. Are young people being led in the right direction? In 1987, Brundtland is the Prime Minister of Norway, who came to Taiwan before. And Brundtland report suggested development that meets the needs of the present without compromising the ability of future generation to meet their own need. This is the definition of sustainable development. So from 1987, when people talk about sustainable development, we have to do sustainable development, always use Brundtland's report, Brundtland's suggestions and development that meets the needs of the present without compromising the ability of future generations to meet their own need. With it, sentence has some problems. When Brundtland came to Taiwan, she was a quite observant politician. She came to Taiwan, first question she asked me, she said, "Hey, Professor Lee, you don't produce oil. How come you're such a big chemical industry? Doesn't make sense to me." That's one question she asked. The other thing is, you guys are interesting. You always send the delegation to Norway and say, Taiwan want to learn from Norway. But people in Norway pay tax. We pay tax, and high-income people pay almost up to 80-90% of tax. And you guys don't pay tax. How can you learn from Norway? In Norway, public schools are free, public transportation are free. Well, how can you learn from Norway? And many faculty members said, among the lecture, said, we do pay taxes. We do pay tax. And how much tax you pay? 25%. Brundtland said, for a professor's income pay 25%, that's not too bad. So somebody must not be paying tax. Somebody do not pay tax in Taiwan. Somebody, high-income people not paying tax. So average government operation is 7% of GDP instead of 40-50% in Northern Europe. There's a big difference. We pay tax, but only salary people paying tax regularly, but lots of people are not paying tax. Well, anyway, so when she is talking about development that meets the need of the present, I asked Dr. Brundtland, what do you mean by development? Produce more, consume more, this higher GDP is called development. Or you go to Poland, Sunday people are sitting in the park, listen to somebody playing piano, playing Chopin's music, enjoying that. Is that the cultural development more important? So I asked, what do you mean by development? Development. You don't just mean the material good consumption, are you? And then I also asked, meets the needs of the present. How much do we need? What is the needs of the present? When I was the president of ICSU, International Council of Scientific Union, I went to South Asia to Africa, very often, and I will go to a very poor village, a very poor country. If you look at the consumption of their lunch and compare to the US, it's only 10%. There's a difference of 10 times in the way consuming the lunch and dinner. So, means the needs of the present. What is the needs? What's the development? What's the need? Then we say compromise the ability of future generation to meet their own needs. The needs of an American or needs of an African or in Bangladesh is entirely different thing. So I do suggest it to her that we might have to look at from globally. So she went back and said, yes, I think about development needs a little more. And actually, we must act urgently, or one day our children will really put us on trial or destroying Earth and their future. We are working on 1.5 degrees, and actually we are working on making our place, Earth system worse and worse. Not as bad as 2 degrees, but it's not going to be any good. So I do want to make some summary. Politically, when we talk about global warming and pollution, this is a global problem in need of global solutions. Probably the local government might not be able to do it all by themselves. Socially, we must turn away from the path of the overdeveloped societies. You look at the US, some of the Western Europe, and Asian countries, we say they are developed countries want to follow the footsteps. That's probably not something we should do. We should re-examine the people on Earth. How can we live comfortably without destroying our environment? Technologically, we must learn to store, to transform, and share energy from the sun. Because after all, sunshine brought us here. We depend on sunshine, whether wind power or ocean energy, all came from the sun. So we have to learn to use sunshine efficiently and store excess energy and transform it so everybody could share energy from the sun. Yesterday I saw the newspaper in Japan is setting in a big turbine trying to harvest the ocean flow energy from ocean flow. Taiwan on the East Coast is really a good place to harvest the ocean flow. And if you go to Australia, you say, well, you don't have enough sunshine. What we do, I sell you sunshine. You come to harvest it. So if you were to be able to rain a large piece of land, harvest sunshine, either split the water or generate electricity and then store it chemically or other way and ship it back to Taiwan, then we might be able to satisfy our need of green energy. But as I said, this is a political problem. Politically, it's a global problem. We need to have a global solution. So we have to turn away from the overdeveloped society pathway and learn to store, transform, and share energy from the sun. If we work together, we might find a way And maybe 2020, 2050, we are talking about zero emission. Temperature will rise to 1.5 degrees. Go beyond. I hope we'll be able to reduce the greenhouse gases and turn the temperature down. That is our responsibility. It's not easy to do, especially young generation. Knew that you have to know we all fail. Older generation has not been successful in doing that, but we have a huge responsibility to turn things around. So I said, we do not have much time left. That's what I mean. We really do not have much time left. Politicians will be gone. Many of us older people will be gone. Young people will come in. Time is limited. Well, let's work together to see how can we improve. Thank you very much.
Okay, we don't have too much time left. We do have a little time for Q&A. Anybody from the audience? Or do we open for the online question? Or maybe from the text, right? Okay, please.
Thank you for the wonderful talk. My question is, as you said, the Asia has so many developing countries, right? And these developing countries would definitely want to follow the path of the developed countries. And they, as we can see in the news, that they are normally denying to control the pollutions. So what can we do in such a way that the desire for the development of the developing countries is also fulfilled, and in the other hand, the emission is also controlled. So what can be the better compromise for that? Thank you.
Well, we should change the idea of how can you make you happy? Many people think that you buy some expensive thing, some so-called delicious food, and drive around, sightseeing, and that's something fashionable or exciting things to do. But as I said, you go to park, listen to music, and without going to shopping center or running around the park, do some exercise, then you don't consume so much energy and make you healthy. So there are many things we have to rethink. It was interesting when I became the president of ICSU. I had a young person who can write, speak English well. He grew up in America. So I told him that we have to be frugal and eat a little less, use a little less. He said, Professor Lee, no way, don't tell me. Be frugal, eat a little less. He says, no way. I said, what way to do it? You do have to do it. So many ideas, many concepts, we do have to change.
Okay, more question? Okay. There's a question online, I think, from, okay, any from the audience now? Yeah, the second question.
Okay, thank you very much, Professor. Thank you for your idea sharing. I saw from your presentation that biomass the portion is in the lowest place as a part of renewable energy. And the second one, from your summary, you propose that to develop energy from the sun. So my question is, what's your opinion about the potential for developing renewable energy from the biomass? Is it potential enough, or can you explain what is the obstacles that to develop renewable energy from the biomass? Thank you very much.
From the what?
Biomass, Professor.
Yes,
Biomass.
Biomass.
all the energy from biomass is again came from sunshine. Biological growth is because sunshine make the plant grow. So those are all so-called energy from sunshine, include the wind or solar panel or ocean flow, all came from sun. Only the nuclear energy or some geothermal energy are the ones which was formed, or which was there when the solar system was formed.
Okay, Professor, I get it.
So geothermal energy in Taiwan we have quite abundant. It's not been used. Nuclear energy, we do have to improve on the kind of nuclear energy we use. We don't want to use the current nuclear energy, generally the waste, which is toxic and also easily transformed into weapon. We can use nuclear energy. We have a next generation of nuclear energy, which do not have the problem of weapon transformation to weaponry or the waste problem. Then science has to make some progress.
Okay, so we have one question from the online.
Yes.
The last one, the question is, could you please give example of overdevelopment society? How do people in overdevelopment societies can live without suffering much from air pollution?
I think we are in an overdeveloped society in Taiwan.
Yes.
And we do not use so much automobile and motorcycles. Pollution certainly will be less. And when I said overdeveloped, it means that if you look at the future for mankind and whether it is sustainable or not sustained in a sense that the Brundtland was saying would really sustain. And many countries are overdeveloped. America, Taiwan is way overdeveloped.
Okay, so I think time is up. Let's thanks Professor Lee again for the wonderful talk.
Once again, a round of applause to Professor Lee, and thank you, Director Chen. And now, on behalf of the organizer, Director Chen would like to present a plate of appreciation to Professor Lee. Please, a round of applause. Thank you so much, Professor Lee, for taking time out of your busy schedule. Thank you.